Where ABCD has side length 1, points P, Q, R, and S each lie on a side of ABCD so that APQCRS is an equilateral convex hexagon with side length S. What is S? We note that we have a square here that we have drawn. We also realize that APQCRS is an equilateral convex hexagon, meaning all the sides are equal length and they take on the value of S. So to draw that out on our diagram, we realize that we have AP, PQ, QC, CR, RS, and ultimately SA. Let's label those AP, Q, CRS. We also know that we can label some sides to be S, S, and S. Since we know that, let's say AD is equal to 1, and we know that AS is equal to S, then we know that DS is equal to AD minus AS, which is 1 minus S. By this, similarly, we realize that DR also takes on the value or the length of 1 minus S. Given these, we also know that since ABCD is a square, then angle ADC has a measure of 90 degrees. So we can perform the Pythagorean theorem on triangle SDR. We know that SD squared plus DR squared is equal to SR squared. Plugging in the values, we have 1 minus S squared plus 1 minus S squared equals S squared. Expanding that out, we get that 1 minus 2S plus S squared times 2 equals S squared. Simplifying, 2S squared minus 4S plus 2 equals S squared, and we can move everything to the left-hand side. We have S squared minus 4S plus 2 equals 0. Now to solve for S, which is what we want, we can apply the quadratic formula, which is X, or in our case, S, is equal to negative B plus or minus square root of B squared minus 4AC over 2A. Plugging that in, we have that S is equal to 4 plus or minus square root of negative 4 squared, which is 16, minus 4 times 1 times 2, all over 2 times 1. This gives us 4 plus or minus square root of 16 minus 8 is 8 over 2. Simplifying a bit more, we arrive at 4 plus or minus 2 root 2 over 2, and that is equivalent to 2 plus or minus root 2. Now we take a look at what is the exact value of S, because right now we have two possible values. It's either 2 plus root 2 or 2 minus root 2. Well, we note that 2 plus root 2 is going to be around 2 plus 1.41, which is equal to 3.41. And we note that S has to take on a value that's less than 1, right? Because S is within the premise of this AD side. So that means this will not be satisfying this condition here. Now we take a look at 2 minus root 2. That is going to take on a value of around 2 minus 1.41, which is around 0.6. That seems to satisfy our conditions. So we realize that our answer is going to be 2 minus root 2, which is answer choice C.